So in this part we are going to look at two-tailed hypothesis testing procedures. So two-tailed procedures. And in the first instance we're going to look at the p-value, then we'll look at the critical value later on. Now, so first step, compute the p-value using the following three steps. So first off, compute the value of the test statistic, lowercase z. Just as a remark, actually, that's a lowercase z. You write the variable for the standard normal distribution as a capital letter, and you use some actual value, not the variable name. You denote it with some actual value as lowercase z. So capital letter means a variable name, lowercase letter means some actual value. Now, if the test statistic is in the upper tail, if z is in the upper tail, that's to say it's positive, find the area under the standard normal curve, the bell curve, to the right of z. Okay, and if z is in the lower tail, which is to say it's negative, find the area under the standard normal curve to the left of z, so the lower tail. So find basically upper tail and lower tail when you're talking about the bell curve, and double the tail area obtained in step 2 to obtain the p-value. Now, in previous cases, I talked about the probability. This is something I mentioned earlier. Probability of z being greater than lowercase z. That is how we compute the p-value for one-tail procedures. So this is a two-tail procedure, so essentially you just double it. So you have one for one tail, one for the other tail. That's the reason. So also what you could do, there's another step actually I could talk about here, and I mentioned it elsewhere, but I will come back to it again here. So what we have in the upper tail, let's draw a bell curve. Let's do white. Okay, let's draw a sort of bell curve just down here in the bottom corner. And there we have it there. So this is our bell curve, our standard normal curve, and what we have is a z, our test statistic here. Okay. Now the area, find the area under the standard normal curve to the right of z. So that means this area here. So you use your tables, statistical tables, to find that. So in this case, it will be probability of z being greater than equal to lowercase z. Okay, and that is from statistical tables, the z tables. Now, so that's how you would do that there. Now, if it was the other side, you'd actually do the same thing. If you remember the symmetry rule, actually I should have room to draw it here, like that. If you have a negative value, oops, hang on a sec, of a test statistic, oh, it's jamming up on me. If you have a negative statistic, you can just use the same approach. You might find that the symmetry rule is a very useful property here. Now, one thing is, what I'm going to do is discuss how you can sort of condense this into one single rule. Essentially, you can use the absolute value function. And where I have in the bottom left there, you can actually replace lowercase z with the absolute value of z. And in that situation, you will not. There's my pen back now. So again, the symmetry rule comes into play here, and there we go. So the symmetry rule. So essentially, according to the symmetry rule, we can. It doesn't matter if it's left or right. We can use the absolute value. Oh lordy, we can use the absolute value of z and just work on the basis of the upper tail here. Okay, so that's that part there. Now, and again, whatever answer you get, double it to get the p-value of the test statistic. because with the idea of a two-tail per test is that you're looking for the area for the two tails. The two green areas here should have the exact same. They do have the exact same area. This area here. So once you know one, to get the combined shaded area, the combined green area, you just double it. Now, using the critical value approach as well, these will occur in both the upper tail and lower tail of the standard normal curve, and use the standard normal probability distribution to find z of alpha over 2, that's the critical value, the z area the z value in the area of alpha over 2 in the upper tail of the distribution. So essentially what you have to do is work backwards. So where you have to find some value here. You have to find this critical value here such that you get alpha over 2 to the right hand side of it, and that requires working backwards from your tables. So alpha over 2, let's say it's 0.025, which is 0.5% over 2, or 0.05 over 2. That will give you a alpha over 2 of 0.025. Now, when you're looking at statistical tables, you have to search through the tables, get as close as you can to this. You find the row number, and you find the column number. So whatever the row number is and whatever the column number is, that gives you the critical value. In this case, you should get it on row 1.9 and column 0.06. 0.06, let me draw that in again. And that means the critical value in this case will be 1.96. So that's just a quick remark on two-tailed hypothesis testing.